In this video, I'm just going to go through some common exam questions that come up on the periodic table. The first question here, they've given you a little snapshot of the periodic table, and they've asked you from the position of beryllium, which is over here, what's it most likely to be? It's on the left-hand side of the periodic table, so I know that it is going to be a metal. Okay, a halogen, it would have to be here in group 7. To be a compound, it wouldn't be on the periodic table. The periodic table only shows elements. It doesn't show any compound. Remember, a compound is two or more elements chemically combined. And it's not going to be gas at room temperature if it's a metal. Metals are solids at room temperature. Give the symbol of the element that's in period 2 and in group 3. Group 3 is going to be 1, 2, 3. So you're going to be looking over here. Okay. Period 2, and this is a really common mistake. Period 1 is here with hydrogen and helium. Period 2 is here with boron. And it asks you to give the symbol, so I'm just going to write the B. State the number of electron shells in an atom of potassium. Again, all you need to do is just see what period potassium is in. Hydrogen is period 1, lithium starts period 2, sodium is period 3, potassium is period 4. You could also draw out an electron shell diagram of potassium. You will have your periodic table with you in the exam. And if you look at the actual periodic table, you'll see that it's got 19 electrons. If you draw that out, you will see that it's got 4 shells. But much, much quicker is just to use what they've given you here and count 1, 2, 3, 4. Just be aware that lithium is the start of period 2, not the start of period 1. This question asks you for the electronic configuration of a calcium atom. Again, it tells you it's got 20 electrons. So if you wanted to, you could draw out an electron shell diagram and then see what you've drawn, what fits with what they've given you. But again, much simpler. You do have your periodic table in the exam. Is see what period calcium's in. So it's in period 1, 2, 3, 4. What group is calcium in? 1, 2. So I know it must have 4 electron shells because it's in period 4. And there must be 2 electrons in the outer shell because it's in group 2. So I come down here and I know I need 4 electron shells, which gets rid of A straight away. I know it can't be A. It gets rid of D straight away. And then I know I need 2 electrons in the outer shell, which gets rid of C. And then that just leaves me with B. You're putting 2 electrons in the first shell, 8 in the second, 8 in the third, 2 in the fourth. This adds up to 20, which is the number of electrons you're supposed to have. You've got 4 electron shells, 2 electrons in the outer shell, which fits calcium being in period 4 and in group 2. How does the position of barium show that it is a metal? So if you look at the periodic table, barium is in group 2, which they do tell you here. It's on the left-hand side of the periodic table, which is where you find your metals. They've drawn potassium for you and they've just asked you what the electronic configuration is. So you can use this diagram. You can see they've put 2 in the first shell, then 8, then 8, then 1. And if you come down here, you'll see D is 2, 8, 8, 1. If they hadn't drawn that for you, you could either draw it yourself. You've got a periodic table. It will tell you potassium's got 19 electrons and you could draw this yourself. Or again, you could just look and see what period is potassium in, what group is potassium in. It's in period 1, 2, 3, 4, so it has to have 4 electron shells, and it's in group 1, so there should be 1 electron in the outer shell. Therefore, when you come down here, you know straight away it can't be B and it can't be C because you don't have 4 shells, and you know it can't be A because you don't have 1 electron in the outer shell. That only leaves you with D, 2, 8, 8, 1. The next one, the relative mass of an electron. A few things you can say here. You can either write the word negligible, which tells you that electrons are so light that their mass is insignificant, or you can write a numerical value. There's a couple that are accepted. You can write it in fraction form, so you can write 1 over 2000 is accepted, 1 over 1836, 1 over 1840. You can write it in decimal form. So there's a few numerical answers that are accepted. Personally, I just learned the word negligible and just always use that. But what you absolutely cannot do is write 0. So you do need to give some numerical value or the word negligible. And just pay attention to the question. You're asked for the relative mass. If they wanted the word negative as the answer, they would have asked you for charge. This time you're being asked for mass. The next question is really common and it's for 4 marks and it's really, really easy. They want to know how electron configuration relates to the position of an element in the periodic table. And that phrase there, electronic configuration, often throws students off. It just means how the electrons are arranged. So if you look at groups in the periodic table, what do elements in the same group have in common in terms of their electrons? Elements in the same group have the same number of electrons in their outer shell. So all that there gets you 2 of your 4 marks. I've abbreviated outer shell to OS. Don't do that, okay? Write it out in full. Same group, same number of electrons in their outer shell. All right, then you've also got elements in the same period. They have the same number of electron shells. If you're in period 2, you've got 2 electron shells. Period 3, you've got 3 electron shells. Those points there will get you another 2 marks. So that's what you're going to write for your 4-mark question. You're not going to get anything for talking about elements are arranged in order of increasing atomic number, because you're specifically asked for electronic configuration, and atomic number relates to the number of protons. That's all the exam questions I've got here. What I haven't included is questions on Mendeleev, so make sure you do still revise Mendeleev. He was the guy who created the periodic table, and the periodic table he created is quite different from the one that we've got today. So know how he organised his elements on his periodic table, and just some general differences / similarities between his periodic table and the modern periodic table.